Okay, can you see my slides today?
Yes, sir.
Okay, so you guys have entered. Okay, we have entered our last chapter. This one is a electrical system. I'm not sure whether tomorrow I will teach you or not. So today I'm filling the class on behalf of Pak Hendra. So yeah, let's start the class. Okay. So this morning we are going to discuss about the electrical system used in chemical plant. Okay. Basically, it's just same. Everyone is going to be same. Okay. Electricity is going to be electricity. Okay. Unless you use your time machine and goes to century of maybe 23rd century, if we still exist, if humans still exist, or 24th century, maybe it's going to be different. But practically in every chemical plant, electricity are managed. Okay, they are managed similarly to each other. Okay. Okay. So actually, when you are quite curious, there is a publication, I'm not sure, maybe from AICHE. Okay, it was written at in the middle of 20s, okay, 1920s. Okay, 1920s or to 1930s. Okay, so it's almost same to our institute age. Around how many years? 100 years ago. Okay. Okay. At the time, some group of researchers and not researchers, I think some group of engineers, okay, and plant owners, they try to incorporate the electricity to their chemical plant. So they tried it and it was good, and you can guess that the chemical plant existed in United States. Okay, so it was the center of technology since the beginning of the 20th century. So that's all. That's for the history. Okay. After that, during the World War, Second World War, and then until this moment, electricity cannot be separated from any healthy chemical plant. Okay, you cannot run any chemical plant without any electricity. Okay, that's normal. Okay, so the electricity itself is used variously, okay, in chemical plant, and since the electricity is easily transmitted, okay, it's like water. Okay, but why do we use electricity? Because its versatility. Okay, it's due to its versatility. Electric wave, okay, electric current can be transmitted easily as long you have potential difference. Okay, different from the heat, and also mechanic. Okay, the transmission of heat energy requires good insulation. Why? Because the heat might lose to some of its portion can be absorbed by our environment, and it's not going to be good. Okay, and for the mechanic, okay, for the mechanic energy, it can be transformed to the heat energy, unwanted heat energy. Okay, when you rotate your, I'm not sure, maybe in your home you have mechanic. Do you have mechanic fan? Okay, when you rotate that fan, some of your mechanic energy is transformed to the heat due to friction. Okay, and we also don't like it. Okay, so electricity energy is the key factor of many industries because it can be transmitted, okay, easily with minimized power loss for its transmission. Okay, I will explain to you later. Okay, and typically for any chemical plant, electricity is used not for its core process, but it's heavily used for control. Okay, you cannot control modern reactor without any electricity. That's the fact. Okay, you cannot control modern compressor without any electricity, even though your compressor was moved by steam. Suppose you still need to do the you need to do the control by using electricity. You cannot open the actuator without using electricity. That's all. Okay, especially for any chemical plant, use electricity for its reaction. That's the heart of chemical plant. What kind of that? I mean, what type of chemical plant that use electricity in its core? You can see the smelter. Okay, you can see the chlorine plant, anything like that. Okay, they use electrolysis. So when you still remember, in North Sumatra, there is a big dam in there. It's called Asahan Dam. Okay, and Inalum, you know Inalum. Okay, it was built. Okay, near to the Asahan. That Asahan Dam. Okay, was built to provide electricity used for Inalum, if I'm not wrong. Okay, you can imagine how big the electricity is used in that chemical plant. Okay, Inalum is also categorized as chemical plant. Okay, so even though it's called a smelter, but still chemical plant. Okay, so during modern modern age, okay, in order to solve many problems, you need to master. Okay, you need to master the electricity. You need to master. You need to shift your energy transmission to the electricity. Many people say that electric car is a waste of effort. Okay, why? Because it was also charged by electricity, and the electricity was originated from coal plant. Okay, from the power plant that is fueled by coal, and they said it's more polluting compared to conventional car. But in that manner, okay, or in modern times, we have an attempt. Okay, we have an effort. It's called the CCS, carbon capture and storage. You can imagine if your car, okay, your car, this one is fueled by the gas, okay, can you capture the CO2? No, you cannot capture the CO2. Even more, you can also produce many other things, CO2, SOx, okay, due to sulfur content inside your car, or inside your fuel, okay, and many other things. But if you have electricity car, even though suppose this one is electricity, okay, you can call it electricity, okay, electricity, okay, and this was charged by power charge, something like this, and this one was originated from the chemical plant. Suppose this one is steam power plant, okay, maybe coal power plant. We can still capture CO2 from its emission. Why? Because the volume of CO2 produced from the coal plant is quite reasonable for any chemical plant owner to recapture it, because it's very huge. Okay, the amount is very huge, and you can capture it economically. Okay, it's quite economic. Okay, compared to this one. Okay. Okay, I'm endorsing this technology. Okay, I'm not endorsing any brand or any car producer, but I'm endorsing this technology to you. Even though this electric car is being charged by the coal-based steam plant, okay, coal-based electric plant, okay, but this one is still, I mean, we can still capture the CO2 economically, okay, compared to capturing the CO2 from your car, okay, because capturing CO2 is not an easy job. You need to do absorption and then storing it, okay. And can you imagine for the absorption of CO2? I'm not sure, maybe the pressure is supposed to be higher than 10 bar, okay. And can you imagine what happens, okay, if you still remember the, what can I say, the diesel cycle, okay, it's like this, okay, something like this, isn't it? Okay, if you need higher pressure, means, okay, you have P4, you have P1 in here, not sure, 1 2 3, oh sorry, this one 3, this is 4, this is 1, sorry, my bad, right? Okay, in here you need to cut at this place because the pressure needs to be used for absorption, and you can imagine that diesel engine has quite low efficiency. It's less than 40%, I believe, maybe 25 or 30%. And what happens if P4 over P1 is reduced due to the requirement of this absorption? You can imagine that our car will have lower power. Okay, so that's not good. Okay, so that's why I'm endorsing this technology. I'm promoting this technology. Okay, for any newer generation, I really require you to open your mind and accept this electricity technology. In the future, we will depend very much from, I mean, this will be our backbone of technology, okay? Backbone of power source and also backbone of power transmission, okay? Yeah, that's all. Okay, so usually for any chemical plant, we do the on-site generation. Why? It's simple. Our electricity provider, okay, PLN, okay, is not strong enough to supply our plant. Why? Yeah, because I mean, its production, okay, the PLN or our country's electric producer has its own limit, okay, because they produce, suppose in this day they produce 50 megawatts, they will need to deliver to the consumer 50 megawatts of, suppose, 220 volt, 220 volt, 50 hertz, 50 hertz. I'm not sure. Maybe if tomorrow I can still teach you. Maybe and tomorrow we'll still have another schedule. I will show you a video. Okay. I'm still actually until this day I'm still researching that video. Okay, I lost it. Yeah, that video about the electricity supply versus demand. So if this PLN supplies us with 50 megawatt, the consumer, okay, so, or maybe if the consumer said they need 50 megawatts, then the PLN, okay, will have to supply 50 megawatt, okay, maybe plus minus 0.1% or 0.05%. Okay, why? Because when we have electric generator, okay, suppose this one is steam turbine, okay, this is the something like this generator. If the load is not same with the amount of electricity produced by us, okay, or by them, okay, the electricity will be tripped. Maybe you still remember about the maybe at the year of 2019. I'm not sure, or 2018. You still remember about a whole blackout of Java and Bali Island during that time due to a single power generator trip. You still remember that? Maybe 2019.
Yes, sir.
Okay. Why? Because in Java, suppose I'm drawing you this Java island, okay, something like this, okay. In Java, okay, this is Madura Island, okay. In Bali is in here, okay. There are multiple, okay. There are multiple electric generator, multiple electric plant. Here in Probolinggo, suppose we have Python, okay. Here we have Jatiluhur. And here we have also in Gajah Mungkur in here, okay. Here we also have maybe Sutami in East Java, and so on and so forth, okay. This transmission, okay, needs to be synchronized. Why? I will explain it to you. Maybe Pak Hendra will explain to you. Why? Because electricity is distributed in what? In wave, okay? The electricity produced is an alternating current one. So in wave. What happens, okay, if this wave is not synchronized, okay, instead of giving the electricity to its consumer, it will be something like this. What happens if we have something like this? It's negative interference, thus the current delivered will be zero, isn't it? It happens okay. A lot. Okay, that's why when you are suppose when you apply your job to Indonesia Power or PLN, you will need to optimize the power usage and power produced for any electricity dam, okay, water-based electricity, okay, in this dam, okay. Suppose this one is the dam, okay. So and this one is generator in here. This one is turbine, okay. Something, and this one is water level. Let me change the color maybe, okay. This one is water level, okay. Usually in this type of dam, okay, they will produce quite little electricity, quite small electricity at the daylight, okay, at the day, during the day. Why? There are two purposes. First is to synchronize the needs, okay. Let me give you some, maybe this one can be used as an analogy. At the day, suppose people will only use 40 megawatt. At the night, people will use maybe 60 megawatt. I'm not sure. Because during these days, many people still use air conditioner at the day, okay? So yeah, maybe the difference is gonna be smaller compared to, and even at this morning, okay, since my room is quite dark, I had to turn on the lamp, okay? So yeah, maybe the difference was not that big, but still big, okay? And this one, something like this, okay? This one also the kit. in here. Okay, suppose something like this. Okay, during the day they open a little so that multiple generators in here they maybe out or maybe two during the day, and they produce around. That's very first purpose of operating half of generator during the day, and then second purpose was to increase the level of water to prepare for the night. Okay, to prepare for the night. Okay, maybe at the day maybe like this, at the night maybe quite a little bit higher. And then after we entered Maghrib time, okay, so dusk time, okay, when the sun is set, they change. 4 out of 4 are operated in 100. So during the night, they increase their power supply from 40 to 60, okay, by opening all of generator gate in here and using their saving, okay, because they have saved quite a lot of water during the day. So that's the work of conventional water-based electricity plant. Okay. Okay. Can you understand about what did I say? Okay. Okay. So if a big plant, suppose Pertamina, okay, Pertamina refinery unit 1 till 5, maybe they ask from the PLN, the PLN will be having they will have a trouble. Okay, why? Because even with this capacity, okay, they can barely supply us. Actually, like that. Okay, even more during the drought season. Okay, during the dry season, the drought season. Okay, maybe August or July till October, where there was no rain, they will have difficulty. So if the chemical plant, okay, because typically chemical plant needs megawatts, okay, megawatts of electricity. If they ask the supply from PLN, then the PLN will be giving up, okay, we cannot do it because we don't have any capacity to supply your needs. That's the fact actually, okay. So most of chemical plant, especially in remote area or especially in Indonesia, because we don't have quite reliable power generator from our country, okay, even though we have many of them, but I'm not sure the technology, the transmission technology was not quite good. Okay, they do the on-site generation. Okay, let's our own power generator so that we don't bother UPLN. Okay, and what another thing is when they buy, okay, when they buy the electricity from PLN, they will need to pay some amount of money. Okay, they increase the operating expenditure, even though in on-site generation they also have to spend their money. Okay, capital expenditure. So in chemical engineering, trade-off like this is OPEX, here is CAPEX, always like that, and you need to optimize both of them. Okay, so you have studied about the cogeneration, you have studied about many heat engine, external heat engines such as Rankine cycle, and or internal heat engine such as Brayton cycle, diesel cycle. All of them actually are needed to generate electricity. Mainly, all of them are needed to generate electricity. Modern plant doesn't require gas turbine compressor, something like that. No. I mean, they can still be used, but in rare occasion. Okay. Usually, the gas turbine was used to produce electricity. Okay. Or maybe steam turbine compressor, something like it. It's not likely in this modern age. Okay, all of the compressors, all of the primary movement, all of the plant control will need electricity. That's why you studied Rankine cycle, Brayton cycle, diesel cycle. Okay, in order to fulfill the plant requirements. Okay. So when you are deciding, okay, when you are deciding what kind of power generator will be built inside your plant, you need to consider the fuel, okay, the fuel availability first. What kind of fuel can be provided to your plant? Whether you can use the coal, you can use the liquid fuel such as diesel fuel, okay, or you can also use the gas fuel, LNG or LPG. I'm not sure. I mean, it's just gas fuel. Okay, you need to think. Okay, what kind of fuel can be provided to your chemical plant? What kind of equipment needs electricity power? So when you are deciding what I'm gonna, you need to balance between the the power delivered versus the load. Like I said to you before, this load must be calculated from the needs. Okay, maybe here controller, office, what else? Compressor, what else? Heater. Okay, and from the power delivered, we need to consider what type of turbine. What type of turbine? Okay. Gas turbine, steam turbine, or maybe just diesel engine. Okay, if your plant was not quite big, just diesel engine because it's easier. Okay, when you it's the most difficult thing to control is steam turbine. Okay, it's very non-responsive. Okay, because you always have a furnace first. From furnace goes to boiler. Okay, from boiler goes to turbine, and then from turbine it will go to your electric generator. First step. Okay, it's difficult to control, but it provides higher flexibility of fuel. Okay, you can use coal in there, or maybe you need to use gas turbine. Even though it's less complex compared to the steam turbine, it requires a skilled operator. It requires periodic maintenance more than gas steam turbine, I suppose, because its RPM is very high, and any of the turbine blade, okay, for turbine blade, any of the material must withstand very high temperature, like been taught by me. Okay, the temperature might reach 900 or 1000 degrees centigrade. Okay, during the combustion of your fuel. Okay, or maybe you just need diesel engine. Okay, so by learning on how to calculate the efficiency of each cycle, Rankine, Brayton, diesel cycle, you can decide what kind of turbine type needs to be installed in there. Okay, and after you install the turbine type, okay, you need to match with the load. Okay, sometimes your turbine type cannot match your needs directly. Suppose you need 20 megawatt but the generator sold in the market maybe 5 megawatt maximum. So what will you do? You need to buy 4 of them, maybe 5 of them. Okay, one is backup. Okay, and then fix it maybe in parallel. Okay, and after fixing it, you need to synchronize it. Like I said to you before, multiple generators always need to be synchronized. Otherwise, your electricity will be tripped. Okay, trip means shutdown. Okay, in chemical plant, there is when anything is turned off suddenly, it's called as trip. Okay, trip. Just so you don't want to see this in your chemical plant. Okay, because it will broke many equipment. Okay, and for the starting up, okay, usually chemical plant its own power plant, they always have the backup, very backup the backup. What? Diesel engine. That's the most versatile, even though it has the lowest what can I say, efficiency. Okay, okay, okay. When you usually when they start up, okay, they always turn on the diesel engine first, and then after that they turn on the controller. After the controller is turned on, then slowly they start up their main generator. Either it is gas turbine generator or steam turbine generator, something like that. Okay. After the generator is being started, they need to synchronize the frequency, okay, and the phase. It's difficult. Okay, that's why we have a department in ITB. Okay, a study program. It's called a power. Okay, in electric School of Electric and Informatics. Okay, electrical engineering and informatics. There is a study program in there. It's called power. Okay, so they learn about this one. Okay, okay, so example of power generators. Okay, this one is the simplest one. Okay, diesel power generator. Suppose you ever done camping or glamping? Okay, glamorous camping. Usually you can see this unit beside your camp area. Okay, it's very versatile and very compact. You can bring, I mean, this one is big. I mean, we can miniaturize diesel engine easily. Okay, and this one is gas turbine one. As you can see here, gas turbine always needs quite sophisticated control compared to the diesel engine. Yes, because it works in very high temperature and very high RPM. That needs to be controlled very carefully. Okay. And the third one is steam turbine. Okay. So this one, the furnace. I'm not sure. Maybe this one, I'm not sure. Maybe some of this is the generator. Okay, the steam turbine or anything like that. Okay. Maybe this one is boiler. And this one is the furnace. Or I'm not sure. Okay. Anyway, it's more complex, getting more complex and more complex. And controlling in the term of control, okay, and for the controlling aspect, this one is the easiest one, number one. Then followed with this one, number two, and this one is the last. Okay, controlling steam turbine power plant is very difficult. Okay. Okay. But the thing is, this is your plant. You somehow you still need to do the tie-in. Okay, from the outside. Why? What happens? Because in any engineering discipline, we must design any fail-proof. Okay, we need to have backup of our backup plan. Okay, plan B is not enough. Okay, you need to have plan C to back the plan B up. Okay, so sometimes, okay, in any chemical plant, they will still need to do the tie-in or the transmission. They need to connect the transmission to the PLS. Why? I'm not sure, but it's more like to increase the reliability of your chemical plant. And since the PLN supply is quite limited, you need to choose carefully which electricity usage needs to be switched. Okay, possibly is office and control. Okay, because you must not operate any chemical plant blindly. And actually it happens in refinery unit 4 in Cilacap, Cilacap, there was a blackout. Okay, there was a blackout. The generator used to power the electricity in the plant was tripped. I'm not sure. Maybe it was due to unsynchronized, or maybe just due to the equipment maintenance. I'm not sure. I didn't know. But the effect was quite severe. At that time, if I'm not wrong, one reactor was broken, almost killed its operator, I believe. Okay. If I'm not wrong, the reactor was called as fish breaker. And then, because that reactor used very high temperature to crack the oil, the crude oil, it needs to be controlled more carefully. But if the controller is shut down due to the power trip, that's a problem. Okay. So when you are dealing with electricity, okay, in these days, you need to have plan A, plan B, and plan C. Okay, maybe plan D. Okay, maybe the controller is powered. Okay, control maybe is powered. Maybe the controller is powered by steam generator. That's your plan A. So your plan B, okay, is diesel generator. That's your plan B. And plan C is PLN. That's, but you still need one more plan. Battery. Plan D. Okay. Well, you are designing your plan, you need to have this type of consideration. Okay. In many cases, when this one is tripped, this one needs to be synchronized a little bit longer. That's why this one kicks in. The battery is kicking in. Okay. And this, the PLN is powering the control room, and the battery usually powers the controller up till maybe 5-10 minutes. But the controller, okay, the operator must be able to see what really happens in our equipment, because that's dangerous. Okay, when if you still remember the case of Fukushima, okay, what happens to the Fukushima? The diesel generator, okay, because they fixed the diesel generator lower than water, okay, lower than water level on the sea. Okay, it's underground. I'm not sure, maybe for the stake of neatness, okay, or the stake for the environment. I'm not sure, but I don't know why did they design the generator, the diesel generator, in lower level of their floor, because they are facing very dangerous nature hazard. What? Tsunami. Okay, the word tsunami was invented in Japan, means they have many tsunami events. Okay, that's why maybe for the sake of aesthetics or the sake of beauty of the place, they put the generator underground. And when the tsunami happened, maybe year of 2010, isn't it? If you still remember, Fukushima. Yeah, I was in Korea at the time. I did not eat any tuna until 6 months because I was afraid the tuna might contain radioactive, and I did not want to get exposed by rain at the time. Why? Because the rain was quite dangerous also. Okay, you can see. And then at that time, their diesel generator, their diesel backup generator was broken. Okay, due to the tsunami. And the diesel generator, after that, their plan B when their plan B failed, they don't have any plan C because they are the PLN itself. Okay, because they are provider of the energy. They're the main source of the energy of that area. So, because nuclear plant is actually a steam plant, isn't it? Nuclear plant uses, this is nuclear reactor. Okay, water comes from here. Okay, maybe come from outside. And here they have what? Not an advanced one. It uses reactor and controlling it because it needs to be lifted and which rod need to be inserted. It's difficult. And the tsunami kicks in. Okay, this generator is off. Okay, plan A is off. Then they have plan B. Unfortunately, their diesel generator is in here, also being flooded. Then plan B is off. What about the plan C? Oh, they don't have plan C because they are the plan C of every user. They don't have plan C. They only have plan D. Okay. Even their plan D can only create the reading, not controlling. Because when for the next semester, when you study the process control, okay, there is always indicator and controller. Okay, there are, even though they can access, they both of them can access in a one single equipment, those two require different energy. Okay, indicating, only if you have only indicator, it has a very low energy consumption compared to control. And it happens in Fukushima. What happens? The reactor reached what? Critical mass and then exploded. And then they have triple events in there. Okay, triple unfortunate events in there, triple disasters in there. What? So first was the earthquake, and then second was tsunami, and then the third one was the nuclear disaster. And why do we need to design any of our system reliably? Because we don't want to see this one. Okay. It also happened in Cilacap. Okay, a place full of fire, maybe last week or last 2 weeks. Okay, due to the light. Okay, it was burned, not burned. The fuel storage tank was burned. Okay, there was fire in there. Okay, it happened in that time, in that place. Okay, due to the electricity blackout, the controller was off, and the operator did not know what happened and inside the reactor, and all of them were evacuated. Okay? So for you, any of you who will work, I believe some of you make a plan, I hope. Please consider this chapter carefully. Okay, maybe you will forget the calculation of this chapter because you will have an excuse. Okay, because I'm not an electrical engineering person, I don't really need this calculation. But this aspect, even though this one is rarely discussed in our class, rarely discussed in real chemical plant. Why? Some chemical engineers just consider that electricity is taken for granted. Okay, it's there, it's our privilege. Okay, but when the electricity is shut down, then the disaster usually happens. Okay, that's why you need to consider how can we provide and transmit the electricity. Okay, okay, because this one is the transmission. Okay, and this one is the backup. Okay, and this one is the load. Okay, and this one is the optimization. Okay, only that, not not difficult. So okay, actually I'm gonna close this class soon. So in chemical plant, electrical voltage not but we also have power plant. Okay, this one is not quite representative. Okay, wait, I have more representative slide. Okay, in the plant you can generate electricity from many things. Okay, and yeah, you can use plan A, plan B, plan C. And let's go back to your first year class. Okay, did you learn about the alternating current during your first year class? Can anyone answer me?
Yes, sir.
Did you learn about it? Okay, yes. Okay, why did you learn this one? Because you need to study about the electricity, modern electricity. Okay, normally in your battery, okay, we use the direct current. Okay, why it's called direct current? Because it's not alternating. There is no anything like this. Okay, okay, yeah. Okay, and for this type of power, we can deliver quite smooth. Okay, current after fix some capacitor, after we fix any electrical configuration in here. But for alternating current, we have two coils in here. Okay, and it's quite different. Okay, the coil is fixed like this. So you still remember the basic law, okay? The right hand rule, okay? The electricity will have different wave, okay? Okay. So why we use alternating current here? You can imagine in a transmission line, there is a power loss potential, okay, resulted from the resistance of our wire, okay, and this power loss is getting bigger, okay, when our current is bigger. So if you still remember, it can also something like this, okay. So what happens if we reduce this one by increasing the voltage, okay? That thing we can how can we reduce the energy loss? Actually, it's simple. We can reduce the resistance or we can increase the voltage. Okay, reducing resistance means you are gonna need to change all of your wire, or increasing the voltage. Simple. By increasing the voltage, you can reduce the current, and this one you will have reduced power loss. And how can we increase the voltage difference? We use transformer, okay, and this one can only be used in alternating current, okay, not in the direct current, okay. Okay, any question? I will close the class today. No? Okay, then let me conclude the class today. Okay, electricity is important. Okay, it controls many things. And you need to consider this one. Okay, even though you are not electrical engineer. Okay, if there is no question,
Sir, I have a question.
Oh,
Would the PowerPoint be uploaded in the Edurnex because I can't seem to find it?
Oh yeah.
Yes.
Okay. Okay. Because it's different PowerPoint. Okay. Last year I did not teach the international class. Okay, actually this one is quite basic, very basic. I mean this one is quite different. Okay. I will send you the
All right, sir. Thank you, sir.
PDF. Okay. I will send Pak Hendra upload it. Okay. It's just know my pattern. Okay. I always teach you from the basic actually, but this morning I got some suggestion from Pak Walmiki. He said that the application is more important, so I started from the application. So if suppose tomorrow I'm going to teach you again, I'm not sure, maybe Pak Hendra will teach you tomorrow, I will do the calculation. Okay. And he also has received my slide. Okay. So this calculation is important. Okay. Why? You will know it later. Okay. Okay. Any other question? No? Then let me conclude this class. Thank you very much for your attention. Have a nice day. See you tomorrow. No, maybe Pak Hendra will see you. Okay. See you.
Thank you very much, sir.